Hello and welcome to Introductory Data Science. My name is Sarah Jensen and I'll be going over the tools and techniques we'll be putting into practice on our first steps toward a career in data science. So the first thing we're going to do is discuss the data science process, sometimes called the data science cycle, because there's a component that we often repeat. So broadly speaking, data science is about transforming data into understanding, insight, and hopefully action. So I like to think of this process as something like reading a self-help book. First, we need to be able to read the book, but we also need to be able to process and understand the message that's trying to be conveyed by that book. We might need to reflect on what that message means for our personal life and our personal application. And hopefully, if it's a self-help book and we're reading it, we want to ultimately take some action based on what we learn from the book. And that's the analogy that I like to use when thinking about the data science life cycle. So the first step is the reading step. And the way that that goes with a computer is we need to import our data. For us, we are going to be using something called an IDE, which stands for Integrated Development Environment. In this specific class, we'll be using RStudio. When we import data, we're transferring that data from wherever it lives, maybe a file, a website, a database, into one common location, the IDE, where we can work with and manipulate and analyze that data using a programming language. And in this particular class, we'll be using R for that purpose. So this is analogous to the process of just reading the book. The second step in our process is tidying the data, sometimes called cleaning the data. I'm not positive that this has a direct analog to the reading the book process. This would be analogous to something that you do in writing, which is like revising and editing your work. So most of the time when we first get our hands on our data, just like a rough draft when you're writing, the things that we see there aren't exactly what we would ultimately want to see. There's going to be some mistakes, there's going to be some anomalies, some things that don't really feel quite right. And what we need to do is revise and edit all of that data, or revise and edit all of that writing until it looks really nice and neat and clean, and other people could read it and work with it and understand it. So that's the tidying or cleaning process. And this is a big time-consuming part of the process with data science, as it is with writing, that is often unglorified. So be prepared to spend a lot of time in this step. Now, even after we've cleaned up our data and made it much more readable and easy to interact with, it's often the case that the data that we're given doesn't contain all the information that we really wish we had, but we could often compute it from what we do have. Examples of this might be filtering your data just down to certain subsets that you really care about, maybe averaging some data, maybe aggregating some data together that looks like it might be different, but we really want to think about it as the same. These are examples of ways that we might transform data, take the data that we have, and maybe change it slightly into something that's a little bit more meaningful for us for our particular context. This might be analogous in the self-help book reference to saying, like, maybe I only want to look at certain chapters of the book, something we might want to read more about, etc. So the process of taking the nice data that we have and maybe changing it a little bit until it looks more like what we want is called transforming the data. And although we think of these two steps as separate, tidying data and transforming data, they're slightly different things. There is a similarity between these two steps. And in some ways, both steps deal with managing, manipulating, and working with your data. And so these two steps together are sometimes called data wrangling. So something very important to remember is that even though we're using computers very heavily for our data processing, there's still a huge human element to data analysis and data science, and humans do best when they can look at a picture. And a thing that I'll say over and over and over again every time I teach a data science course is that graphs and visuals are the things that are going to go across your boss's desk. So do not underestimate the power of a strong visualization. This is really how humans understand and interpret data the best. So after you've gotten all the data you need, we're going to spend a lot of time creating good, helpful visuals to help us really process and understand all that data we've worked so hard to get the way we want. However, computers don't do so well with visuals. That's not what a computer is best at. A computer is really best with the raw numbers and with mathematical models. So modeling is to sort of return us back to the computer part of this process. Models are predictive tools that we are going to use to answer questions about novel data that might be similar to the data that we've just worked so hard to see and understand. This is really where data scientists earn their worth, is in mathematical modeling, by saying, okay, I worked really hard to understand this data that you gave me. How can I take what I've learned and apply it to a new situation that's similar? Can I predict what will happen then? That's really the power and the reason that we're putting all of this effort into understanding the data that we have is for hopefully its predictive ability. So when we build mathematical models, these are going to be tools that our computers can use to make predictions for us, and this is going to be a really valuable part of the process. Now, this is a data science course, and anyone with a history in science will have experienced the phenomenon of answering one question only to have 7 more. This is true of data science as well. It is often the case that once you've put all the effort into transforming and visualizing your data and trying to answer one question, you'll start to notice more and more things and become inspired to ask further questions. And one can imagine that maybe if you come across a new question that's the result of earlier analysis, you might not have actually transformed your data to fully understand the second question. So you may need to go back to the beginning of that transform part to compute some new things to start over to answer a new question. So sometimes we work in a cycle here with this process of transforming your data, looking at it, coming up with a model, and then all of a sudden, oh my gosh, I have this new question, but I don't quite have the data set up that way. You can return to the transform stage to set the data up that way, and then look at it and answer the new question. So you can stay within this cycle as much as you need to or have time for, as is often the case. And this collection of 3 steps together is really where you get that understanding of the data that you have. Perhaps last, but absolutely not least, is the communication aspect of it. So visualization is a very human process, but communication is a very human process as well. Once you understand something, you really need to be able to communicate it in order for people to take actions on the insights that you've found. If the purpose of analyzing the data was to understand it and maybe make some changes, those changes won't come about unless you can convince other people of the worth in what you're doing and the reason that a change would be a good thing. Forming those good communication skills to take your understanding and then disperse it to others. This is a very important and human part of the process. The steps that we have outlined up until this point, from importing data all the way to communicating data, these are all of the steps of the data science process. But surrounding all of this is programming and programming skill. We are using a computer in many of the steps of the data science process because a computer is a workhorse. It is capable of performing huge amounts of computations at speeds that humans cannot reach, but a computer is just a workhorse. It will not do any of these tasks on its own. It will only do exactly what we tell it to do. So we are going to need to spend a certain amount of time learning how to communicate with the computer in what's called a programming language in order to get the computer to do the things we want it to do all that hard work for us so we can spend our time on the human parts of the data science process. For what we'll be doing in this course, we do not need to become computer masters. We do not need to become expert computer programmers, but there's this really wonderful learning curve where a little bit of programming will get us very far and really help us speed up a bunch of things and get to a deeper level of understanding than if we would have tried to do this all on our own.